Okay, so for this is number 16 on your review, okay? And we notice we've been doing lots of transformation stuff. So what we're going to do here is to describe the transformations that would have occurred to the original y equals f of x function, and then apply it to the graph of y equals x squared, or f of x is equal to x squared. So first things first, what we're going to do is write down in part A the transformations that would have occurred. So for part A, starting from left to right, I can see that there has been a vertical reflection in the x-axis. Okay, and then there would have been a vertical stretch by a factor of 2. Now, we got to be a little bit careful with the inside, okay? So what I'm going to do is maybe just shuffle this over here. I'm going to rewrite this. It's called negative 2 f at, now just be careful. I'll use the square brackets. We're going to have 1/3 out front, okay? And then we're going to have x. I've basically factored the 1/3 out, and so what's going to happen here is when I take 4 divided by 1/3, that's going to equal 12. Okay, so I'm going to have x plus 12 on the inside, which isn't going to work very well for our graph when we go to graph x squared, but that's okay. Okay, and then minus 1. So we've taken care of the two components on the outside so far. That's the vertical reflection and the vertical stretch. Now we're going to go to the next thing that I see, and that next thing is going to be a horizontal. Remember, it's 1/3, the opposite of, we're going to do the opposite because it's on the inside, so it's a horizontal stretch. Oh boy, this is really not going to fit on our grid. Stretch is a bad question on the textbook's part. Stretch by a factor of 3. Okay, and then now we have the two horizontal, or the two translations, right? So we're going to have a horizontal translation because it's on the inside of the bracket. It's a horizontal translation left 4 units. And then we're going to have a vertical translation down 1 unit. Okay, so what we're going to do, we're going to take our base graph of y equals x squared for part B, right? And we're going to transform it accordingly. Okay, so first things first, it's being asked us to reflect and stretch by 2. That should turn into this graph here. 2, 4, 6, 8 takes me to there. Takes me to there. And 0 stays at 0. Okay, so this is going to be the graph of that's going to be the graph of f of x is equal to, oh, we'll call it g of x, sorry. G of x is equal to negative 2x squared. Okay, so that takes care of the first two, and now I need to go, that's these two, sorry, first transformations. That'll be, I'll check mark the ones in blue, and then we'll do the purple. So we'll horizontal stretch. Okay, will be the next transformation we apply. So horizontally stretch, 0 stays at 0, 1 goes to 3, and 1 goes to 3, and then 2 goes to 6. Okay, so we're going to get, the graph's obviously going to get wider if I horizontally stretch it. I think that goes to there. So our graph should look like this. I'm not going to stress too much about the fact that this is not going to really fit on our grid. On the test, I'd obviously give you questions and that fit. Okay, so what we're going to do now is, oh, sorry, I made a mistake up in here. I knew it wasn't going to fit and I wrote down the wrong thing. We are referencing It's going left 12 units, okay, and that's come from, just let me bring your attention to that, 12 units, left 12 units, okay. So obviously that's not going to fit, but what we can do, we really just need 3 points for the most part for a quadratic to kind of get an idea. It's helpful to have 5, but we'll move whatever we can, okay. So yeah, 12 is not going to fit. So again, what I'm going to do is grab all these purple points. They're all going to move 12 units to the left, which unfortunately takes us off of our grid. Like our graph's going to be kind of in the middle of these words, and then down 1. Okay, so our vertex, here, let me pick a color, the orange, is going to be somewhere 1, 2, 3, 4. Oh, it was close. It's close. The vertex is going to be somewhere in here. Okay, and the graph is going to go pretty wide. It's going to look something like this. Okay, just that purple graph, but shifted to the left, or translated to the left 12, and then down 1. Okay, it would be somewhere there. Again, on the test, I'm going to make sure that the question I give you fits on the grid that I've provided. But you can see the base graph is the red one. The final transformed graph is going to be what we will call, sorry, I'll write these in. H of x is equal to -2. It might actually be helpful to see the equation. So 1/3 x plus 12 squared minus 1. Okay, that's what that would look like as an equation. Okay.